Hi friends, see today we will be discussing about new chapter, that is gravitation. Okay, so gravitation chapter, in gravitation we have hardly 2 marks in MSET. So today we will be dealing a new chapter that is called as gravitation. Okay, so what is gravitation actually? See, it's a universal phenomenon. That means according to Newton, suppose if you take any point masses, m1, m2, 2 point masses, please, not a uniformly distributed mass, point masses. So suppose the distance between the center of masses, say r or d. So according to Newton, the force is directly proportional to product of the masses and inversely proportional to square of distance between them. Inversely proportional to square of the distance between them. So combining 1 and 2 equations, you will have F proportional to m1 m2 by d square or r square. So here, if you remove the proportion and introduce a constant k into m1 m2 by r square or d square, this k is called as g, which is Newton's universal gravitation constant. Into the Newton's universal gravitational constant, and its value also is there given by Sir Isaac Newton, 6.67 10 to the power of minus 11, its value. And what are the units? SI units, Newton meter square per kg square. So this value you have to remember in the examination. They will be asking regularly, what is the value of G? G is universal gravitation constant. It is constant anywhere in the universe, anywhere. So if you put it here, F is equal to capital G m1 m2 by r square. So this is the formula for Newton's force of attraction between any two bodies, okay, on that surface. Please make a note, this is only applicable for point masses. Now what are the things given by Newton regarding this force of attraction? See, gravitational force. So gravitational force according to Newton is always an attractive force. Identity always attractive. Because in electrostatics second year we are having Coulomb's laws. It is repulsive as well as attractive. But Newton's laws, Newton's gravitational force is always attractive force between the two bodies. Okay? And how it is acting along the line joining between center of masses. It always acts along the line joining between the center of masses, please. So these are very important properties regarding gravitational force. ఇది ఎలా పనిచేస్తుంది? It is always attractive. It is always attractive force. It is not any repulsive like Coulomb's. It is always attractive force between any two bodies on the earth surface. And ఎలా పనిచేస్తుంది ఇది? It always lies along the line joining between the two center of mass of the bodies, point masses. Always along the center of mass it acts. Third one, gravitational force does not depend upon any medium. Okay? And a body's machine even a medium undi, for example kerosene or any liquid placed between two bodies, it does not affect. The force remains constant. Because in electrostatics we have studied, due to medium force is changing in Coulomb's laws. But here in gravitational force it does not affect. If any medium is present between bodies, gravitational force does not affect. These three are very important. Gravitational force is always an attractive force. It acts between the line joining between the two center of masses of the point masses, and it does not affect by any medium between the masses. Clear? Please note down this one, very important formula, Newton's gravitational formula. Because in IPE they will be asking the units also. What is the value? 6.67 in 10 power minus 11 Newton meter square per kg square SI unit. Please make a note, this formula is only applied for point masses. If mass is distributed, for example uniform rod, then you have to apply integration method again. Okay? So finally మనకి ఏమొచ్చింది formula? Gravitational force ఏంటిది? G m1 m2 by r square. Equation 1. Now in this what I'll do is, let us assume, let m1 ni capital M అనుకుందాం and let m2 is equal to small m. Let us assume m1 is capital M, m2 is small m. And this capital M I'll assume as mass of earth. I'll assume as mass of earth, and this one is mass of any other body like a stone or an apple, etc. Okay? M is mass of any other body like a stone or an apple, etc. on the earth surface or above the earth surface. Now if we substitute here, this formula goes like this: G capital M small m by r square. Okay? Now we already know what is capital F from Newton's second law, m into A or m into G. Either it is, you can write it as MA or MG. Substitute here capital M small m by r square. Mm gets cancelled. What is G here? G is equal to Gm by r square. Here R, I will take it as capital R because it is the radius of the earth. I will write R as capital R. Please, I will take small r as capital R. Then it becomes as Gm by r square. So this is the final formula for acceleration due to gravity. G, universal gravitation constant, 6.67 10 power minus 11 Newton meter square per kg square. M, mass of the earth. R is radius G. See, all these values are calculated. See, G value 6.67 in 10 power minus 11 Newton meter square per kg square. Mass of the earth is taken nearly 5.97 into 10 power 24 kilograms or 6.0 into 10 power 24 kgs. Radius of the earth, R is nearly 6,400 kilometers or 6,400 into 10 cube meters, because 1 kilometer is equal to 1000 meters. So when you substitute all these values, G values was found to be 9.8 meter per second square. So this is the value of acceleration due to gravity. Clear? And we have another name also for this small g value. That also I will tell you now. ఇంకో పేరు కూడా ఉంది ఈ స్మాల్ జీకి. ఏంటో తెలుసా మీకు? Acceleration due to gravity, we have another name also. This is also called as gravitational field intensity. ఏంటది? Another name for G, because it's a vector. The another name for this one is, it is also called as gravitational field intensity. Just like in your electrostatics, electric field intensity E bar, it is also a vector. So what is this gravitational field? Already G ante intensity ante Gm by r square అని చదువుకున్నాం. So the other name, it is also called gravitational field intensity. So this vector E bar is also given by F bar by M. So it is the force acting on a unit mass placed in a gravitational field. What is gravitational field actually? Gravitational field ante enti? Just like electric field, gravitational field kuda ఏంటంటే the region or space around a body where its influence is felt. The region or space around a body where its influence ante attraction is felt on another body. దాన్ని గ్రావిటేషనల్ ఫీల్డ్ అంటాం. సో ఇక్కడ గ్రావిటేషనల్ ఫీల్డ్ ఇంటెన్సిటీ అంటే ఏంటి? ఏదైతే మీరు జీ అంటున్నారు, స్మాల్ జీ, జిఎం బై ఆర్ స్క్వేర్. సో ద అదర్ నేమ్ ఈజ్ ఇట్స్ ఎ వెక్టర్. ఇట్ ఈస్ దట్ ఫోర్స్ యాక్టింగ్ ఆన్ ఎ యూనిట్ మాస్ ప్లేస్డ్ ఇన్ ఎ గ్రావిటేషనల్ ఫీల్డ్. అంటే ఫర్ ఎగ్జాంపుల్ ఇది గ్రావిటేషనల్ ఫీల్డ్ అనుకోండి. ఈ గ్రావిటేషన్ ఫీల్డ్లో ఒక మాస్ పెట్టాం అనుకోండి. ఓకే, సో దీని సపోజ్ ఫోర్స్ ఇలా ఉంది అనుకుందాం, గ్రావిటేషనల్ ఫోర్స్. సో ఈ ఫీల్డ్ ఎలా ఉంటుంది దీని మీద? ఫీల్డ్ ఈజ్ గివెన్ బై, field means that is gravitational field intensity, in other words intensity given by F by m, force acting per unit mass. అందుకే యూనిట్స్ కూడా న్యూటన్స్ పర్ కిలోగ్రామ్స్, ఎంకేస్ యూనిట్స్ ఏంటవి? న్యూటన్. ఇంకో యూనిట్ కూడా ఉంది, న్యూటన్ పర్ కిలోగ్రామ్స్ ఆర్ మీటర్ పర్ సెకండ్ స్క్వేర్. ఎందుకు? బికాజ్ ఇట్ ఈస్ ఆల్సో కాల్డ్ యాక్సలరేషన్ డ్యూ టు గ్రావిటీ. వాట్ ఆర్ అదర్ యూనిట్స్ ఫర్ జీ? మీటర్ పర్ సెకండ్ స్క్వేర్. ప్రూవ్ చేద్దామా? చూడండి. వాట్ ఈస్ 1 న్యూటన్? 1 న్యూటన్ అంటే కేజీ మీటర్ పర్ సెకండ్ స్క్వేర్ ఇంటూ 1 కేజీ. చూడండి, 1 న్యూటన్ మీన్స్ వాట్? కేజీ మీటర్ పర్ సెకండ్ స్క్వేర్ బై కేజీ. కేజీ క్యాన్సిల్, ఏం మిగిలింది? మీటర్ పర్ సెకండ్ స్క్వేర్. సో ద యూనిట్స్ ఫర్ G value is, that is gravitational field intensity is, either you can call it as Newton per kg in MK system or SI system, లేదా meter per second square. Very very important అండి ఇది. Okay, please make a note. Very very important. Now we have learned about many things, that is Newton's gravitational law of point masses, acceleration due to gravity or gravitational field intensity. Okay, and as I said, gravitational force is always an attractive force. It is always attracted towards the mass. It is always attracted towards the mass of a body. Now we'll go further. That is, see here, now we have learned about gravitational force between two point masses. Now if you go still further, that is regarding gravitational field, let us know what is principle of superposition also. Principle of superposition అంటే ఏంటి కూడా చదువు. What is principle of superposition? For example, see here, suppose this is one body, this is another body, this is another body, and this is, for example, this is M1, M2, M3, Mn. For example, this is R1, R2, R3, Rn, distances. Let us have so many bodies, M1, M2, M3, M4, so on, and Mn bodies. Suppose at a point O, we have to calculate, for example, net. E point there we want E net. What is E? Gravitational field intensity. So if you want that point O E net, how to get this value E net at that point? That is nothing but principle of superposition. Principle of superposition. ఏంటి ప్రిన్సిపల్ సూపర్? E net is equal to E1 vector plus E2 vector plus E3 vector plus dot 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 En vector. So vectorial sum of all the gravitational field intensities, E1 vector plus E2 vector plus E3, E4, E5 dot 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 En. This is called as principle of superposition in finding out the gravitational field intensity due to number of masses distributed. Due to all this, at O we are finding the net gravitational field intensity. Okay, so this is how we got, that is the vectorial sum of all the gravitational field. Clear? Now let us go further. Now after learning about superposition principle in gravitational field intensity, let us study about gravitational field for different structures. For example, see here, suppose ఇది ఒక arc అనుకుందాం. Suppose this is the arc of a circle. The mass ఎంత capital M and radius r. For example, this is the arc of a circle. Let this is making some angle. Let this is making some angle phi. Okay. So this is the arc of a circle. Now we are trying to find out gravitational field intensity dE. That is, which is nothing but your g, small g, acceleration due to gravity. Due to this one. So just now I told you, gravitational field intensity ఎలా ఉంటుంది? It is always attracted towards the mass. So here for example you take small piece dm mass. చిన్న dm mass, చిన్న ముక్క తీసుకోండి dm mass. So it is towards. Like this it will be dE. Gravitational field intensity. అలాగే ఇక్కడి నుంచి towards the mass. D. And these will have two components, horizontal component. One component like this and another component like this. So these two horizontal components, what happens? They'll cut together. The horizontal components cut అయిపోతుంది. But what about vertical components? Finally in this direction. They'll add up. These components, gravitational field intensity will cut together horizontal, that direction, opposite direction lo kabatti cut అయిపోతుంది. But what about these vertical one? They will add up. D. In the same way, if you take any dm mass, same like that you will be having the field in this direction. Horizontal components will be cutting up and vertical will be adding up. So due to this one, if you want, you can calculate by using a formula. Gravitational field intensity is given by, okay, that is E 2gm by r square phi into sin phi by 2. This is a very important formula. You can calculate gravitational field intensity of different structures like arc, semicircle, quadrant, etc. etc. So allows in the gravitational field intensity with reference to point O, at O, because field will be towards mass. Gravitational intensity will be towards mass. But these two components will be cutting each other and the vertical components will be adding each other. So the net field, gravitational field will be in this direction. And allows in the E bar is equal to 2gm by r square phi sin phi by 2. Please make a note, this phi is in radians. Sorry, it's degrees. Numerator phi will be in degrees, please. Sorry. Numerator phi will be in degrees. And this phi will be in radians. Please make a note. This numerator value phi will be in degrees and this phi will be in radians. Please make a note. This is very, very important. For example, say angle phi 60 degrees. అనుకోండి 60 degrees ఇచ్చాడు phi value, arc angle 60 degrees. So this 60 you have to convert into, this will be in degrees, you have to convert into radians. How will convert? 60 and ఎలా రాయొచ్చు? pi by 3 అని రాయొచ్చు కదా, because pi means 180 by 360. So what will be the value here? For example, E bar, that is gravitational field intensity, E bar is equal to 2gm, capital, that is mass of the body given, by r square. R is the radius. See, R is the radius here. Okay, so r square phi దేంట్లో ఉంచమన్నాను radians. 60 degrees and ఎంత 180, that is 180 by pi. Pi అంటే 180 by 360. So pi by 3, పైకి వెళ్ళిపోతుంది 3 into sin 5 by 2. Phi 60 కదా, 60 by 2 అంటే 30 degrees. What is sin 30 degrees లో? Half. 1 by 2. So this 2 gets cancelled. Finally, what is E? E bar is equal to 3gm by pi r square. So this is a small example only. Just suppose if he gives in degrees angle 60 degrees, how to calculate? The formula is 2gm, because the net field intensity gravity will be in the vertical direction, because these two gets cancelled, horizontal ones. Okay, so this formula you have to make a note, 2gm by r square phi into sin phi by 2. This phi is in degrees and this is in radians, please. Let us go to another figure. Now we will go to semicircle, please. Okay, now let us go to semicircle. Now arc of a circle chesam kada, radius r and mass m. Now let us go to a semicircle. If suppose semicircle is given, how to calculate gravitational field intensity? That is net field. Okay, see here, same formula you can apply for any figure. For example, meeku exam lo, and these questions will be coming not in IPE, please make a note. In MSET and NEET examination they will be asking what is the gravitation field intensity due to arc of a circle of capital M and R radius, semicircle, quadrant, okay, uniform circular ring, all the different cases. Next I will go for semicircle, second one. Semicircle. For example, this is a semicircular piece having mass same capital M and R radius. Now at point O, this is radius R. Same way, okay, you can see if you take any dm mass, same thing what happens, in this direction it will be, okay. So these horizontal forces will be cut off, horizontally veyathunna field idi cut ayipotundi, and those vertical will be adding in this direction. So this is the net gravitational field. So I will get net field, apply the same formula due to the semicircle. In the formula, E bar vector is equal to gm by r square into phi. What is this angle phi? Denominator value radians nu cheppanu. So phi ante pi 180 degrees into sine pi ne degrees lo unchmani cheppanu. Put it in degrees. So pi means how much? 180 degrees. 180 by 2, 90. So sine 90. Since sine 90 is equal to 1, so what will be the value for semicircle? E is equal to gm by pi r square, because sine 90 is equal to 1. Clear? So this is gravitational field intensity for what? Semicircular part. If m is the mass and r is the radius with respect to point O. Same way, the horizontal component will be cut off and vertical will be adding up, d. So the net will be in this direction, towards mass. Now let us go to the next one, quadrant of a circle. Next one is gravitational field intensity due to quadrant of a circle. Next one, gravitational field intensity for quadrant of a circle. Let us go to the next one. Clear? Right. Now let us go to the next one, quadrant of a circle. See. So this is having mass same capital M, R. R is the radius, quadrant making 90 degrees. Here also if you take same dm mass, small piece, dm mass, so it will be what? Towards the mass. Here also the components will be cutting and this one will be adding up. So the resultant will be in this direction, D. Resultant will be towards, because then components rendu cut ayipotayi. Only this one vertical will be adding up. Okay, this component and this component gets cancelled. So same thing apply here. What is E? 2gm by r square phi. What is the angle here? Down is in what? Radians. So radians means ఎంత అవుతుంది ఇది? 90 degrees. You know how to convert that one? Say I am telling easy method. 360 degrees is equal to 2 pi radians. Okay? So 360 degrees equal to 2 pi radians అయినప్పుడు what is 1 degree? Unitary method. 2 pi by 360, that is 2 ones are 2 180s, that is pi by 180 radians. So 1 degree anta pi by 180 radians. So 90 degrees how many? Into 90. 9 ones are 9 2 ఎంత వచ్చింది? Pi by 2 radians. Like this you have to convert. Simple method. So 90 degrees అంటే ఎన్ని radians? Pi by 2. Pi అంటే ఎంత? 180 by 2. So I will write it here. This is what in radians? Pi by 2. 2 pi వెళ్ళిపోతుంది. Into sine. Sine how much angle? What is this angle? 90 degrees kada. So 90 by 2 how much? 45. 45 degrees. So finally, what is the value of E bar? Gravitational field intensity 2 2s are 4 gm by pi r square sin 45 1 by root 2. So then if you multiply with root 2 up and down, this becomes 2 times. So finally, what is the value? 2 root 2 gm by pi r square. This will be the final value. ఒకవేళ quadrant of a circle iste, if they gives in the MSET exam or NEET exam, quadrant, what is the gravitational field intensity with respect to point O? Then it will be towards the mass. Okay, same way the horizontal component will be cut off, vertical will be adding up. So finally, what is the value? 2 gm by r square 5. This is in radians and this is in degrees into sin 5 by 2. So finally, ఎంత వచ్చింది value? 2 root 2 gm by pi r square. Clear? Next one. Next one. Last one in this case, that is uniform circular ring, for example. Last one, what is the last one? Last one ఏంటిది? Uniform circular ring. Okay, so mass is distributed like this uniformly. For uniform circular ring, please, we are going to find out now the gravitational field intensity. Uniform circular ring. You can see here, mass is distributed uniform circular ring. This is center point O. Now at a point P, okay, which is at a distance, suppose say r. Let this distance be r. Okay, now for example, I will take some dm mass here. If I see from here, okay, the same way dm mass. Okay, what happens? Just now I told you, if dm mass is taken, what will be the field? Towards the mass. Field towards the mass, D. Field around is always towards the mass. So, you have the components also for this one. One is like this component D, another component D. As you know, these two in opposite direction cancel. And what about the horizontal? They'll add up. So add up, and the net will be in this direction. So for this, how you will get the value of E? Gravitation field. We have a formula, please note down. G m small r by G m small r by r square plus capital R square power 3 by 2. Okay, small r square plus capital R square power 3 by 2. So this formula, please remember it, where small r is the radius from the center of the uniform circular ring. Okay, in uniform circular ring you can see the mass is distributed continuously. Okay, so this mass is capital M and R is the radius. This is the radius. This is the radius of the ring. So from at a point P, if you want to find out the gravitational field intensity, always towards the mass the gravitational field intensity will be there. So if you take any small dm masses on this ring, it will be towards the mass, and these components will get cancelled, and these horizontal components will be adding together. So this will be the net field now. So the net field is given by G capital M small r by r square plus capital R square small r square, distance of the point from the center, capital R radius of the ring, power 3 by 2. Suppose if r is equal to 0 and అర్థమేంటి at the center of the ring, then E is equal to 0. ఎందుకు 0? యూనిఫామ్ రింగ్ లోపల మాసే ఉండదు. మాస్ లేనప్పుడు ఫీల్డ్ ఎక్కడి నుంచి వస్తుంది? There is no gravitational field. That is where the center, the E is equal to 0. At O, gravitational field intensity is equal to 0, because if R is equal to 0 or 0 by anything, 0. And not only that, inside there is no mass. Okay? When there is no mass, there is no gravitational field intensity. So these bodies, whatever I have given, all these are very, very important regarding NEET and MSET examination. Not in IPE, but in NEET and MSET examination, these questions are coming nowadays. Please remember the formula. Now let us go to the next topic in gravitational. Very, very interesting now. That is, what is acceleration due to gravity? Already I have given the formula. What are the factors affecting the value of small g? This is the next point. Into the factors affecting the value of small g. Very, very interesting and interesting topic also. Now we will be discussing factors affecting the value of small g. అదే ఇందాక మనం డిస్కస్ చేసాం కదా, గ్రావిటేషనల్ ఫీల్డ్ ఇంటెన్సిటీ, ఫోర్స్ యాక్టింగ్ పర్ యూనిట్ మాస్ ప్లేస్ ఇన్ ఎ గ్రావిటేషనల్ ఫీల్డ్. సో దానికి ఏవే ఫ్యాక్టర్స్ ఎఫెక్ట్ చేస్తాయి? వాట్ ఆర్ ద ఫ్యాక్టర్స్? సో దీస్ ఆర్ వెరీ ఇంపార్టెంట్ డెరివేషన్స్ ఇన్ ఐపీఈ ఆల్సో, 4 marks. Now I will derive for you each and every derivations. First we will write what are the factors affecting, and then we will go for derivations. Okay? Now please write down all of you. Factors affecting the value of small g. Acceleration due to gravity. Acceleration due to gravity. దీన్ని మనం ఏమన్నాం ఇంతకుముందు? E bar. Gravitational field intensity, because in electrostatics also that same terms are coming. So that is where the terms are coming outside. In electrostatics it is electric field intensity. In gravitation it is called gravitational field intensity, E bar, vector. Both are vectors. So what are the factors? First of all, write down altitude and the height. From the surface of the earth, if you go in upward direction vertically, it is affected. Altitude is nothing but height. Second one is depth. Okay, that is into the earth surface, into deep into the earth surface. Third one latitude. See, in some books they are giving lambda, some books they are giving phi. Anything you can follow, either you can follow lambda or phi, latitude. You can take poles and equator, fourth one, poles and equator, and last one mineral deposits. So these are the 5 factors affecting the value of small g. The gravitation field intensity indaga ede cheppam, E bar, vector or acceleration due to gravity will be affecting all these 5. Ee 5 kuda examination lo 1, 2, 3. These 3 are derivations are asking the exam IPE for 4 marks. So for your sake, I will be deriving altitude, depth and also latitude. Remaining all are theory parts. Okay? So for you I will derive. Copy? Okay. So let us go for the first one, altitude or height derivation. That means what happens to the, as a person goes away from the earth surface, భూమి నుంచి పైకి కొంత ఎత్తుకి వెళ్తున్నప్పుడు ఈ స్మాల్ g వాల్యూ ఏమవుతుంది? Now see here, suppose let us assume this is the earth surface, radius r. So from here, suppose a person has gone to this height. Let this height be h. Now here I want g dash value. Already on earth surface you know the value of g. What is g value? G by r square. Okay? So first one is due to height, that is altitude, height wala. So due to height means, for example, how to calculate now? On the earth surface, what is force of attraction between two bodies? Capital G, capital M by r square, equation 1. On the earth surface, force of attraction between two bodies, mass of the earth, another is any other body going above that surface. Now we have to calculate at a height h what is new acceleration due to gravity. That is nothing but a gravitation field intensity. Okay, so ee place lo naku kavali, and we already know what is g. G on earth surface, that is gm by r square, equation 2, because we know F is equal to mg from Newton's second law. So if you substitute here, you will get this equation. Now at this height we will get g dash. G dash there anta vastundi gm by, in the place of r plus height. What is the total height now? R plus h. So in the place of r plus h whole square, equation 3. Now I want g dash. So divide 3. See here? Equation 3 divide with equation 2. So g dash by g is equal to gm by r plus h whole square. So with this I am dividing this one. Paiki r square వెళ్ళిపోతుంది, కిందన gm. gm gets cancelled. G dash by g is equal to, what is this value? R square by r plus h whole square. But what I want here finally, g dash kavali. So g dash is equal to g into r square by r plus h whole square. Okay, or otherwise you can also write in this fashion this entire formula. See here, ఇక్కడ మనకి ఎంత వచ్చింది? g is equal to gm by r square, g dash is equal to gm by r plus h whole square. So what I have done here, I have divided this with this. So g dash by g is equal to gm by r plus h whole square by that thing. That means this. So పైన r square cancel అయిపోయి ఫైనల్గా మనకి ఏం మిగిలింది? క్యాన్సిల్ అయిపోయి r square. దీన్ని ఇంకో విధంగా కూడా రాయొచ్చు కదా, ఎలాగా చూడండి ఒకసారి ఈ ఈక్వేషన్ని. I can write in this fashion. G dash is equal to g by 1 plus h by r whole square. రాయొచ్చా లేదా చెక్ చేసుకోండి, ప్లీజ్ చెక్ ఇట్. బికాజ్ చూడండి ఇది ఇదంతా, ఇది యాక్చువల్ చూడండి ఒకసారి, ఇది ఈ ఈక్వేషన్ r plus h whole square by r square ni I can write like this, r plus h by r whole square. This is nothing but 1 plus h by r whole square. So if you transfer that one, finally you will get equation like this here. G dash is equal to g by 1 plus h by r. See, this is always correct. This equation is always right. Okay? G dash, new value here is given by g by 1 plus h by r whole square. And sometimes in intermediate they will be writing, they will be taking to the top. దీన్ని పైకి తీసుకెళ్ళి ఇంకా బైనామియల్ ఎక్స్ప్రెషన్లో రాస్తారు. ఒకసారి చూపిస్తాను చూడండి. This equation also you can write it in this fashion, in binomial expression, that is, see, same equation, if mathematically if you solve it, you will get in this way. See here, same equation I can write in this fashion. G dash is equal to g into, if you take to the top, what happens? 1 plus h by r to the power of minus 2 plus 2 by this calculus. So this is a binomial expression. This is a binomial expression. So ఏమవుతుంది? 1 minus 2h by r, 1 minus 2h by r plus 3h square by r square plus 4h cube by r cube. So you will have some binomial expressions. So ఇక్కడ ఏం చేస్తా? higher coefficients are neglected. Why it is neglected? Because if you compare this height with radius, when h is very much less than r, when h is very much less than r, because you know what is the radius of theirs? 6,400 kilometers. Chala takku, for example 1 kilometer, like 2 kilometer, 3 kilometers, or nearly up to 5 kilometers. When h is very much less than r, then you can go for this formula. ఏంటది g dash is equal to g into 1 minus 2h by r. So when you have to apply this formula, when h is very much less than radius, like 1 kilometer, 2 kilometer, 3 kilometer, up to 5 kilometers. But when h value is larger value, that is half of the radius, like that, you don't apply this formula. Take this formula. Entity g dash is equal to g by 1 plus h by r whole square. Clear? So when h value less baga takkuva unnappudu 1, 2, 3, 4 up to 5 kilometers, you can go with this formula, binomial expression. That is g dash is equal to g into 1 minus 2h by r. R is radius, height is the body which is placed above the earth surface. But when the value is very greater, and for example half of the radius undanukondi, ee formula apply cheyakandi, it goes wrong. You apply this formula. Okay, g dash is equal to g by 1 plus h by r whole square. And this formula is always right, please. Clear? So with this, what you understood? That means as you go above the earth surface, the value of g, what happens? Decreasing. చూడండి ఏదైందో చూడండి ఫార్ములా ఏంటి? g dash is equal to g into 1 minus 2h by r. 1 minus 2h by r. So g minus something, g minus something. So value is decreasing. Okay? So value is decreasing. So as you go above the earth surface, acceleration due to gravity decreases from this equation. It is proved. And already I told you, this formula you have to take when the value of h is very much less, like 1 kilometer, 2 kilometers or up to 5 kilometers. If more value is given, this value you have to take, this formula. G dash is equal to g by 1 plus h by r whole square. Clear? Now let us go to the next one, condition, that is due to depth. Second condition, what happens to the value of g due to depth? Rendo derivation andi intermediate adugutunnadu regular ga. In IP examination they are asking you, suppose this is the earth surface, let r be the radius capital R. Now suppose a person is going inside uniformly cutting the earth surface. For example, he is cutting d meters uniformly. Suppose this is how much? D meters. Suppose he is cutting d meters uniformly going into the earth. Now we want this new radius small r. Okay? Now what happens to the depth? We will calculate. Now as we know, on the earth surface, we know the g value. What is g? G is equal to gm by r square, because we know force of attraction is given by g capital M by r square from Newton's laws of gravitation. Now what is this value on the earth surface? But on the earth surface, what is the density? For example, rho is the density. Density is equal to mass by volume. What is the volume of a solid sphere? 4/3 pi r cube. So 4 by 3 pi r cube. So rho into 4 by 3 pi r cube is equal to capital M. I will put it as equation 1. So this is the mass. Put this mass value here. We will try to calculate what happens here. See here. G is equal to G into M. That is M and ఎంత వచ్చింది? Rho 4 by 3 pi r cube by r square. R square, this cancel upon. So what is the value I got? G is equal to capital G rho 4 pi r by 3, equation 2. This is the value of acceleration due to gravity, density, in terms of density. Now because you are going into the earth by cutting d meters, now what is the effect of rho now? Because radius is changing. As radius is changing, what happens? This value also changes, g value. Radius మారిపోతుంది కదా. Now what is the new radius here? చూడండి. What is small r here? I'll write it here. What is new radius r? Capital R minus d కదా, మారిపోయింది చూడండి. d meters కట్ చేసుకుంటూ లోపలికి వెళ్తున్నారు మీరు. So what is this new radius? Reduce. R minus D. So let us calculate again once again what is G dash. So G dash is equal to again Gm by R square. So G dash is equal to Gm. Okay. Now what is mass here? What will be mass now? Change అయిపోతుంది ఇది. చూడండి. Mass change అయిపోతుంది కదా. We'll change the mass value here. As you know, density is equal to mass per volume kada. Volume ఎంత అవుతుంది? 4/3 pi r cube. ఈ రేడియస్ ఎంత అయింది? R cube. R minus D whole cube అవుతుంది. Because R is changing as you are cutting D meters inside. ఇప్పుడు ఎంత అయింది అప్పుడు మనకి? Rho into 4/3 pi R minus D whole cube is equal to mass. This is the new mass now. Because D meters కట్ చేస్తూ లోపలికి వెళ్తున్నారు మీరు ఎర్త్ లోపలికి. Now put it here. G dash is equal to G into M. What is the value of M? New M. Rho 4/3 pi R minus D whole cube by R square. ఇక్కడ R ఎంత అవుతుంది? న్యూ రేడియస్ R minus D కదా, మారిపోయింది. సో ఇన్ ద ప్లేస్ ఆఫ్ R స్మాల్ r వచ్చేస్తుంది ఇక్కడ. ఈ ప్లేస్ వాట్ ఎవర్ R square is there now. This R square it becomes small r square. సో R ఎంత అవుతుంది? R minus D whole square. So R minus D cube ఒకటి క్యాన్సిల్ అయిపోతుంది. సో వాట్ ఈస్ లెఫ్ట్ ఓవర్ నౌ? G dash is equal to G rho 4 pi R minus D by 3 మిగిలింది. This is equation 3. Now almost we got the equation. See, we will divide 2/3 or 3/2. Okay. Shall we start? Okay. So let us see what happens now. I am dividing these two equations. చూడండి ఒకసారి. I will divide these two. G dash by G. Equation 3. Equation 3 divided by equation 2. G dash. G dash ఎంత వచ్చింది? G rho 4 pi R minus D by 3 by G. సో ఇది రివర్ట్ చేద్దాం. by G rho 4 pi R by 3. సో డివైడ్ చేసినప్పుడు ఏమవుతుంది? క్యాన్సిల్ అయిపోతాయి కదా కొన్ని. చూడ మరొకసారి రాద్దాం ఇది. 4 pi R minus D by 3 into 3 by G 4 pi R. G rho 4 pi 3 3. ఏం మిగిలింది ఫైనల్గా? G dash by G పైన న్యూమరేటర్లో R minus D, కిందనేమో R. This I can make it as 1 minus D by R. Or otherwise, G dash is equal to G into 1 minus D by R. చూడండి ఏమైందో? G dash is equal to G into 1 minus D by R. So G minus again something. So G minus something and again ఏంటి అవుతుంది? Value 9.8 minus something. Again decreasing. So again due to the depth also, as you go deeper into the earth surface, the value of G, acceleration due to gravity or gravitation field intensity will be decreasing. You can see the equation. D is the D meters depth you have gone and R is the radius of the earth. Please note down. Clear? Okay. So these two derivations are very important in intermediate. In intermediate IP examination, board examination, they are asking for 4 marks due to height, altitude and due to depth also. I have given 2 equations for you. 1 minus 2h by r, G dash equal to G into, and another is G dash is equal to G by 1 plus h by r power square. ఈ రెండు ఎప్పుడు వాడమని చెప్పాను? ఫస్ట్ ఫార్ములా బైనామియల్ ఎక్స్ప్రెషన్ యూ హ్యావ్ టు యూజ్ వెన్ ద వాల్యూ ఆఫ్ G height is very much less than r. And 1 kilometer, 2 kilometers up to 5 kilometers. When the value is larger, they should not use that form. You have to go for always correct form. That is G dash is equal to G by 1 plus h by r whole square. Now we will see some conditions for depth condition. See, as I told you, first altitude వల్ల ఏమైంది? altitude or height valla, what is the formula? G dash is equal to G into 1 minus 2h by r. ఇది ఎప్పుడు when h is very much less than r, like 1 kilometer, 2 kilometer up to 5 kilometer, you have to use this formula. Okay? Or otherwise, what I told, always correct formula, G dash is equal to G by 1 plus h by r. This formula is always correct. When the value is greater value. Okay, when the value is little greater, when it's very much less than r, you can take this formula. When little greater, when it is greater value, then you have to apply this formula. ఏంటది? G dash is equal to G by 1 plus h by, ఎందుకంటే పైకి వెళ్ళిపోతే ఇది మైనమ్ అయిపోతుంది. 1 plus h by r power minus 2, that is 1 minus 2h by r. This is second formula. అలాగే due to depth, what is the formula got? G dash is equal to G into 1 minus d by r. So here you can observe one thing, here also value is decreasing due to depth. Suppose let d is equal to r, అంటే మీరు తవ్వుకుంటూ భూమి లోపలికి you have entered into that surface where d is almost equal to radius of the earth. అప్పుడు ఏమవుతుంది ఇక్కడ? G dash is equal to G into 1 minus d is equal to r. అప్పుడు ఏమవుతుంది? 1 minus 1 0 0 into g 0. సో G dash ఎంత అవుతుంది అప్పుడు? 0. నో గ్రావిటీ. ఇప్పుడు గ్రావిటీ ఉంది కాబట్టి మనం నిల్చున్నాం భూమి మీద. గ్రావిటీ లేకపోతే ఏమవుతుంది మనకి? విల్ బి ఇన్ ద ఎయిర్, ఫ్లోటింగ్ ఇన్ ద ఎయిర్. See, because your gravity is there 9.8 or 9.0, you are standing on the surface of the earth. If G value completely 0, no G value, then you will be floating in the earth. That means if any body is kept or any body is poured, anything is poured, liquid like, it will be on the surface and it won't come down because G value is 0. ఇది ఎక్కడ జరుగుతుంది? At the center of the earth, you can see. At the center of when D is almost equal to R. So there, no gravitation, acceleration due to gravity. There the body will be in the air only, floating in the air. No, it won't come down because G value is almost 0. Not even jumping also, it will be in the air. So these are the things you have to understand regarding altitude and depth condition. Now, another derivation is also left over. That derivation, this is part 1, I think gravitation part 1. Hardly this gravitation chapter will divide into 2 or 3 parts. Either 2 parts will end up this chapter or 3 parts. So another derivation is also there due to latitude, poles and equator also there. So remaining all I will be dealing in the next part of gravitation, that is part 2. Okay.